Hey boys and girls. Okay, today I'm going to teach you a new math concept that we were going to start last week. But unfortunately it has been pushed back to this week. Now, it is not the easiest fraction concept to learn, so we're kind of going to go over it a few different times over the next week or so. And that's okay. And it's going to be especially kind of tricky to try to teach it to you where we're not there together. But I thought maybe this video would kind of help that a little bit. You are going to need, in your math packet that you got, you are going to need to get this worksheet out, this fraction strip one, because this fraction strip worksheet is not actually one that you will use for anything per se. I mean, I guess I shouldn't say you wouldn't use it. You'll use it a lot. But you will not, there's nothing that you're going to do on it. You're just going to kind of use it as a reference to look at, kind of like you do with your skip counting chart. On your skip counting chart, you don't do anything on it, but you use it as a resource to help you when you get stuck. So as we go through and we're doing equivalent fractions or figuring out which fractions are bigger than one another, this is just going to be like your resource that you need to keep somewhere and make it like the almost as important as that multiplication skip counting chart that you got way in the beginning of the year. It is about that important for fractions. This sheet is right here. It's in the middle of your math packet somewhere. Okay, so what I'm going to do is I'm going to demonstrate with Legos what equivalent fractions mean. And then I'm also going to post another equivalent fractions video for you on the math section of the extended break thing. You probably already have a link to it. And I'm going to want you to watch my video. I want you to watch that video. And then I'm going to show you kind of what I'm going to have you do on this sheet right here. Okay, so I'm going to kind of put this off to the side because you don't need that right now. Just kind of have it handy for you. Okay, so this is equivalent is just a big fancy word for equal. So if you see something that asks for equivalent fractions, that just means fractions that are equal to one another, okay? So right here, I dug through my kids' Legos and I found this one. This is gonna represent like our one whole, okay? This is like if I have one whole thing. So like on this sheet right here, it is kind of like this big long thing that has a 1. Okay, and I'm going to show you something. Now, equivalent to one whole, if I put 2 of these pieces underneath, you'll notice that they are the same size, okay? 2 of these together is the same size as one of those. Again, kind of like if you look at this sheet here, the 2 1/2 are equal to the 1 whole. Okay, so I'm going to take these and I'm going to put them on top like this. And then down below it, I'm going to write that if I have 2 halves, here's 1/2, there's 1/2, it would be equal to having one whole thing. Okay? Next, what I'm going to try to do is I'm going to see if I can find something that's equal to a half. So I'm going to take off one of my halves, okay? Because if this is my whole, each of this, here's 1/2, here's another 1/2. I'm going to see if I can find something that is equal to this half right here. Let me get this out of the way. And if I look at the other Legos that I have, if I were to try, for instance, this right here. Here I have 1, 2, 3. This would be like one whole that's broken into, what do you think? Hopefully you said thirds. This is like if you have one whole thing broken into thirds. See how it's equal to the one whole? But now this time it's in 3 pieces, so this would represent thirds right here. Now, if I take one of my thirds and I line it up here with one of my halves, are they equal? Are they the same size? And hopefully you are like, no, absolutely not. Because yeah, no, they're not the same size at all, okay? What if I had 2 of the thirds? If I have 1/2 of the thirds, is that equal to having 1/2? No, it's not either. Okay, so thirds are out. Sorry, thirds, get out of here. Okay, because I'm trying to find something that's equal to 1/2. Okay. Here's my 1/2 again. Okay, so now I have 4 of these right here. 1, 2, 3, 4. These 4, this is a whole that's broken into 4 pieces, so this one would represent fourths. Okay, my whole is split up into 4 chunks, so this is fourths. Let's see if I can figure out any fourths that would be equal to my 1/2. Okay. Is 1/4 the same as 1/2? No. What if I had 2 of the fourths? Put all my fourths there. Those are. So now what I'm going to do to show that those are equal is I'm going to say, okay, 1/2, this was my 1/2. Let me get rid of this up here. 1/2 is equal, it's the same as if I have 2 of the fourths. So these would be equivalent fractions. 1/2 and 2/4 would be called equivalent fractions because they are equal. Okay, so let's try to see if we can find another one. Let's kind of mess around here. Now, if you were in class with me, you would have gotten Legos and everything, and I would have said for you to play around until you found something that was equal, and you could have gotten to play with them. If you got Legos at home, you can play with them. Okay. Maybe bonus points or bonus dojo points if you find something else. Okay, these. Let's see what these are. If I put these together next to my 1/2. Okay, let's move my fourths. Move my thirds. Okay. Here's my 1/2. Here's my halves. 1/2, 2/2. Okay. Let's see what these are broken into. 1, 2, 3, 4, 5, 6. Okay, so these are sixths. Sixths. That's that one that's really fun to say because you can't say it. Sixths. Okay. Do you see any sixths that are equal to the 1/2? Let me bring the 1/2 up here. Let's see. You should notice that, look, let me move these out of the way. Here's my whole broken into sixths. And if I line up my 1/2, 1, 2, 3 of the sixths are equal to 1/2. So then over here, and you slide this over, I'm going to write that same thing. 1/2 is equal to 3/6. Okay, I want you to look at these because I want you to see if you can notice, if you notice anything about any pattern between getting from 1/2 to 2/4 or from 1/2 to 3/6. Take a second, see if you can figure out there's a pattern in how to get from this 1 to the 2 and from the 2 to the 4. And on this one, there's a pattern to get from here to here. And it's the same pattern that you use to get from here to here. Okay, so think for a second. What's a way that you can get from 1 to 2? If you get from 1 to 2, let's write it again over here. And it's the same thing that I would do to get from 2 to 4. So some of you might be thinking, well, I can add 1. Okay, so 1 plus 1 would give me 2. But if I did the same thing down here, 2 plus 1, does that give me 4? No. Here's the trick. If you multiply the top and the bottom by the same thing, it will give you something that's equal. So like to get from 1 to 2, I had to multiply times 2. 1 times 2 gave me 2. And the same thing down here. To get from 2 for my denominator to 4, I also multiply by 2. 1/2 is equal to 2/4 because in both circumstances, I multiplied the denominator and the numerator and the denominator by the same thing. I multiply this by 2. 1 times 2 is 2. I multiply this times 2. 2 times 2 is 4. That's what makes them equal, or that's a trick to figuring out if they're equal. Here, same thing down here. I'm going to move the 1/2 and the 3/6 over. 1/2, 3/6. Okay, so same thing. If you were multiplying, how do you get from 1 to 3? 1 times something gives you 3. 1 times 3. If you wanted to get from 2 to 6, what do you multiply by? 2 times 2, 4, 3. Ah, look at that. Okay, so there's your pattern. However you multiply to get to here for the numerator, as long as you multiply the same by the same number for your denominator, it will be equal. Okay, so there's a trick. Now, on your paper that you see in your math packet, this one, you're going to notice that if you look through the lines, some spots the lines are in the same spot as somewhere else. So for instance, if I look through this, if I look at the 1/2 right here, and it might help like if you had your crayons or your colored pencils and you colored them, if I colored in the 1/2 piece, and then I went up here, and then remember how we found, and I colored in 2 of these 4ths, I've colored in the same amount because 2 4ths is the same as having 1/2. And we already talked about that. That makes 2 4ths and 1/2 equivalent. If I go up to the 6th, there's the one that we just did. How many of these 6ths are equal to 1/2? Well, follow your lineup. Oh, look, 1, 2, 3 of the 6th is equal to 2 4ths. 3 of the 6th is also equal to 1/2. What about 8ths? So if I look at 8ths, if this is 3/6 right here, if I color in that same section, if I color in that same amount on my 8ths fraction strip, 1, 2, 3, 4/8 is equal to 3/6. It's also equal to 2 4ths, and it's also equal to 1/2. Because if I cover this up, these are all equal. Because they are, if I have the same color, or I'm sorry, the same size hole, this has the same amount as this, and as this, and as this one. Okay, so what I'm going to have you do is on the Google form that you have that's called equivalent fractions, I'm going to ask you things like, how many tenths are equal to 4/8? So then let's do that one here real quick. How many tenths are equal to 4/8? Well, here's 1, 2, 3, 4/8. Color them in. How many tenths up here are equal to that? 1, 2, 3, 4, 5. Oh, 5 tenths. And if I were to say, well, how many 12ths are equal to 2 4ths? Find your 2 4ths, look how big it is, then go up to your 12ths and look and see how many of those would be the same amount. And if I wanted to go even further, I could. Like if I wanted to say 1, 2, maybe I wanted to go 3 4ths. Do you see anything if I follow this line up that's equal to 3 4ths? Okay, look on yours while I'm looking on mine. Oh, look. If I followed this 3 4ths line, 3 4ths goes to here, and if I follow that up, I notice it looks like it's awfully close to these 8ths. So let me color in that much of my 8ths bar. 1, 2, 3, 4, 5, 6. So 6/8 is equal to 1, 2, 3 of the 4ths. And if I followed it up again, I want you to tell me, and I'm not going to tell you this time, how many 12ths are equal to the 3/4. Okay, let's try one more. Just because, I mean, you know me. Like, I get into it and I just can't help it. How many sixths are equal to 1/3? Here's a third. Follow it up. How many sixths are equal to that 1/3? 2/6. If I pop this out and I put it here, it will be the exact same size. And here, let's even show it on my Legos. How many thirds, or I'm sorry, how many sixths are equal to 1/3? So let me get my third here. Okay, here's my third. It's a third of this size. Okay, here's my third. Third. Here's my other third, my last third, my third. How many sixths are equal to just one of my thirds? Because remember, I needed 6 of these little guys here. Okay, there we go. How many sixths are equal to one of these thirds? 2 of them. 2 sixths are equal to 1/3. Or if you wanted to flip it around, 1/3 is equal to 2 sixths. It would go that way too. Okay, so this is our next big concept that we're going to be doing. So now that you've seen this video, I'm going to have you go onto the Google form, and you're going to need to use this page that's in your math packet. And you're going to need to go in and use that page to help you answer the questions that are on your Google form, because it's going to say things like 2 sixths is equal to how many thirds, and you will have to tell me it's equal to 1/3. Okay? If you have any questions, just send me a message on Google Hangouts if you need to, or on Dojo, or just use my cell phone number and give me a call. Talk to you guys later. Keep working hard.